everyone. Welcome to our Wi-Fi deployments webinar. Today we have Marc Hemann, Training Manager at Cambium Networks, and Ray Savage, the Director of Product Marketing at Cambium Networks, with us today. So before we begin, I do want to mention really fast that we do have a questions tab in the control panel. So during the presentation, you feel free to ask any questions and we will get to them either during or after the presentation. So without further ado, I will pass it on over to you, Ray.
Thanks very much, Riley. Thanks everybody for joining. Today's a great presentation on how to do Wi-Fi network design and do it right. Marc's been designing networks with multi-radio high capacity networks for a long time, and he's here to share some best practices with us. And Marc, I guess everybody says planning is very important. I'm assuming you'd agree.
Oh, absolutely, Ray. You know, it's an overlooked art, I believe, in the industry. Too many people, I think, are very busy and they design a network. You know, they go to some kind of Wi-Fi designing tool and they design a network and they place APs and they get a real pretty picture of a heat map, and it covers everything just perfectly. And that is one step, just one step in the overall process. But a lot of times folks are so busy, that's the only step they take. So in today's webinar, I'm going to cover the other steps that are equally as important, or in some cases even more important. So I'm going to cover the entire process of what I've learned and the things that I think are important when correctly designing a Wi-Fi network and getting it correct the first time. So with that, Riley, can I ask you to advance a page, please? Perfect, thank you. So, you know, so here's what's going on. You're going out to a customer and you talk to the customer. You find out they need a Wi-Fi network, and there's lots of different reasons, but it's your job to dig deeper because there's a lot of information that needs to be discovered up front before you start placing access points in some kind of Wi-Fi designer tool. Okay, and these questions will lead to the success of the overall project, or if not followed properly, you could be in some trouble. But let's go over some of these discovery questions that you need to ask, and you need to have this type of information. The first is, you know, business requirements, the user requirements. Why is the customer installing a Wi-Fi network? Did they get a new voice over Wi-Fi phone system, or are they planning to buy one? Do they have an existing one? Do they have an existing Wi-Fi network? What's the pain points on this network? Is it poor performing, or does it not roam properly? Is it just not meeting their needs? You need to find these things out. You know, ask questions on the WAN link. Okay, the capacity of the WAN link. Ask questions about the existing LAN, the switches, the routers, that whole infrastructure. And ask if they have an existing wireless LAN. Again, how is it performing? Where are the APs? Things like that. Sit down with the customer and, if possible, pull out a floor plan. Ask them very specifically what areas of the floor plan need to be covered. Okay, and what is the type of environment? Is this a storage area that needs little to no Wi-Fi coverage, or maybe it's sparse offices, you know, just a very few people. Maybe it's a cubicle farm. Maybe it's an auditorium or a cafeteria. All those questions need to be answered. Okay, and now it gets real important. Ask about the clients. Okay, what type of clients are going to be using this Wi-Fi network? Is it desktops? Is it laptops? Is it iPhones? Is it tablets? Is it all of the above? Because that's going to tell you what kind of signal strength you need. You know, back in the day when we designed Wi-Fi networks, everybody had a desktop, and you could design a RSSI level across your entire network at 72, neg 72, and that would be okay. But in today's world, with these very low power devices, your iPhones, your tablets, you need neg 65. And in some cases, if you're designing a network for medical purposes, your RSSI needs to be about neg 62. Okay, so find out what type of clients you're going to be using or are going to be using the Wi-Fi network. How many clients are there, and what applications they're going to be using. Okay, and in those applications, you'll probably have to do this homework, but you'll need to find out what type of bandwidth requirements these applications are using. So for instance, a Zoom call, okay, a Zoom call per person on that group can consume up to 10 megabits per second of your bandwidth. When you have 2 or 3 people on a call, it's no big deal. But what if you have 50 people in an area on this Zoom call? It becomes a big deal very, very quickly. Okay, so that leads up to this next point, latency requirements. If you've got a lot of Zoom calls or Teams calls, any kind of video and audio, especially audio, your latency has to be as low as it can possibly get. Okay, signal strength requirements, coverage requirements, capacity requirements. These are all really good questions. Security. If you're going to, is the customer using a radius server, or are they just doing, WPA2 802.1x with pre-shared keys? You need to know that. Layer 2 and layer 3 roaming. Layer 2 works straight out of the box. You really don't have to do much as long as you've got the network designed properly. No big deal. But layer 3, if you're using voice over Wi-Fi, layer 3 is going to be critical if you have somebody with a Wi-Fi phone that walks across the building, maybe into another building, and hits a different subnet. Okay, so that's layer 3 roaming. It's a lot more difficult to implement, but you need to know that going forward. What kind of onboard security? Intrusion detection systems, mobile device management systems, network access control systems is the customer currently using or plan to use in the future. Okay, are they doing any kind of guest access? And this one's really critical. Find out if there's any design constraints or restrictions. A lot of times in older buildings or fancy buildings, they don't want to see access points hanging from the ceiling, so you've got to hide them, whether it's behind a pillar or above a ceiling tile or something like that. But those things need to be taken into consideration. Okay, Riley, next one, please. Okay, Wi-Fi design principles. Well, again, designing the network is not just all about pulling up your Wi-Fi designer and placing access points on a floor plan. It's really about getting the math right. The success of your network is contingent on you doing the math right. And when I'm talking about getting the math right, I'm talking about finding out what kind of clients are going to be using the network, how many are going to be using the network, where they're located, what applications, and the bandwidth requirements. You've got to do that math. You have to figure out how much bandwidth each client requires, okay? And then you start to design your network around that. You want to design your network for both 5 gigahertz and 2.4. Now, I'll tell you a little shortcut here. When I design networks, I design only for 5 gigahertz. Okay, and then when the design is finished, I'll add 2.4 just to make sure I've got the coverage. 99.9999% of the times, I'm good, because 2.4 is a lot stronger band than 5 gigahertz. Okay, understand the impact of device density. Okay, so and I'll get more into this in just a few minutes, but Wi-Fi is a limited medium, only so much bandwidth per radio. Okay, and every time a client connects to the network, they get a piece of the pie. Okay, so you can have 100 devices connected to one radio, and if they're all doing pretty much nothing but email and some casual web browsing, then everybody's going to be really happy. But as soon as they start to go to Netflix or YouTube and start to, or make Zoom calls or Teams calls, and they really start to use the network, then guess what? Your network's going to crash because of the applications they're using. Okay, so know what the clients are going to be doing, and that's where you can figure out how many radios are going to be required in an area. Okay, if it's low performance, like I talked about, just casual email, casual browsing, 80 devices on a radio, okay, it's okay. Medium performance, you don't want more than 40, and for good performance, like you want in the most offices, 20 is about the max. Again, depending on the applications and the bandwidth requirements of those applications. You should plan when you're placing APs, and I'll talk about this more, but when you start placing APs on the map, you want to have a 20 to 30% overlap on your coverage there. And the last bullet here, this is huge, because a lot of people don't know what 802.11a, b, g, n, ac, and ax mean, right? I'll use my wife as a good example. If I start talking to her about Wi-Fi, it takes about 3 seconds and she's out, she's gone. But so how can I ask her, hey, is that an 11ax client that you got? That Apple, is that 11ax? She don't know. But if I ask her, is that Wi-Fi 6? Oh, she'll know what that is, because Wi-Fi 6 is better than Wi-Fi 5, right? But make sure that your customer understands that when they see that alphabet, A, B, G, N, A, C, A, X, only A and AC guarantee that they have a 5 gigahertz client. Okay, and we want all our clients to connect to the 5 gigahertz radios. So educate your customer that if it doesn't say A or AC, it's not guaranteed 5 gigahertz. They need to do some additional research. I've seen school districts go out for bid and go out and buy 500 new laptops that are BGN. And they think, oh, well, there's N, that's 5 gigahertz. Well, no, N is 2.4 or 5. And so they just bought 500 new laptops that have a 2.4 gigahertz radio only.
So Mark, let me ask you a quick question here. Is it easier or more difficult to design a Wi-Fi network that's replacing one instead of just a greenfield where they've never had it?
It's probably easier to replace an existing network. The reason being is that the customer should already know, what areas are clean and what areas are having issues with Wi-Fi. Because one of the things that you have to worry about going into building this network are RF interferers. Okay, are there devices in the area that are going to interfere with the Wi-Fi signal? And in an existing network, a lot of times they already know, oh, we've got Wi-Fi in this area and it's pretty good. We don't have any issues, or maybe we're doing something over here in this area, and for whatever reason we've just never been able to get it to work properly. So they can give you the heads up like that. But otherwise, it's always a really, really good practice to do a spectrum analysis of the environment, whether it's greenfield or whether you're replacing an existing one. So it may be a little bit easier with an existing network, but don't take too many shortcuts with it. Thanks, Ray. Okay, planning for your or something to look at during your planning phase is the WAN and the LAN connections. Okay, your connection to the outside world, your wide area network. Look at the existing infrastructure. If you have a bonded T1 going out to the internet, and you're going to expect 100 of your employees to do Zoom calls, guess what? That's not going to work, right? So check those connections. Check that router that's on the edge. If it has a 10 megabit uplink port to the WAN link, that's not going to work. Okay, so check those kinds of things. If you're going to be using existing switches, okay, are they PoE switches? And if they are PoE, what's the power budget? Are those old switches going to effectively power up these new access points, especially these new Wi-Fi 6 access points that have software definable radios? Those guys require up to 35 watts of power. So any older PoE switch is not going to be able to supply that, but you need to know that up front. Okay, cable drops. If you can use an existing cable drop, by all means. Okay, make a note of where those cable drop locations are. Let me go back to switches for a second. Look at, if you're going to be using existing switch ports, what's the power? What's the speed of those ports? If they're 10-100 ports, guess what? You don't want to hook up your APs to a 10-100 port. It needs to be hooked up to a 1 gig port, or in some cases, like the XV3-8, our Wi-Fi 6 through radio access point, that needs to be hooked up to a multi-gig port. Our EX2016 MP switches have a series of 2.5 gig ports for those XV3s. By the way, those same ports also supply 802.3 BT power. That is power sufficient for those high-powered APs. And here's something that folks don't really think about, and I've seen more than one company run into this issue. They don't plan for DHCP IP addresses, okay? Because they'll come in, they'll install this new network, okay, this new wireless network, and guess what? You have to have an IP address for every access point, okay? And then you have to have an IP address for all these new clients coming on the network. So if they haven't been paying attention to their DHCP pools, they can run into issues pretty quick because they're just going to run out of IP addresses. Okay, so look at that, have that discussion with the customer. Also, and I think I mentioned this, in one facility you can have a lot of different environments. Storage areas, warehouse areas, office areas, auditoriums or cafeterias. Okay, all these different areas have different Wi-Fi requirements. Okay, and I'll get into that here just a little bit more. So next slide, please.
Yeah, Mark, just a note here. Based on our question about rip and replace, or whether it's easier to do greenfield or a replacement, Paul made the comment, can you also design to coexist with an existing infrastructure and fill in holes? And I think the answer's got to be yes.
Yeah, the answer is yes, but be very, very careful. If you can use the same manufacturer, that's probably your best bet. And here's why. I'll go back to roaming. Okay, roaming at layer 2 is critical for any Wi-Fi network. I mean, that's the purpose of a Wi-Fi network, is the mobility, right? You want your clients to be able to roam from access point to access point to access point as they walk through a building. When you look at the spec, the 802.11 spec, roaming is now, they're tightening it down, but it wasn't always so tight. Okay, the IEEE would give you some requirements on roaming, but they didn't tell you how you had to do it. Okay, so each manufacturer had their own algorithms for roaming, and some manufacturers say, oh, well, we do roaming better than anybody else, so we're the best AP out there. Everybody had their marketing spin on it. Okay, so layer 2 roaming, which is straight out of the box, works pretty good, even with different manufacturers. Okay, layer 3 roaming, forget it. It will not work with different manufacturers. But really, the bottom line is try not to mix manufacturers when you're just plugging in an AP to fill a void, to fill in a hole. Try to use the same manufacturer. Just more than anything, you know what you're getting, but also if you start to have problems in that area, troubleshooting those issues will be a lot easier with one manufacturer than with multiple manufacturers.
Great, thanks. And another tip here from Adam, who says that doing your survey, make sure that the switch is providing the PoE is also a 48 to 52 volt DC and not just 24 volt.
Oh, good point. Yes, thank you. You know, that's something I tend to not even think about, but that's a very good point, Adam. Thank you. Yeah. Okay, looking at planning for your Wi-Fi capacity, and this page here really kind of explains what I've been trying to say. You know, when you're planning on how many radios need to go in an area, you know, again, what type of clients, how many clients, what applications are they using, and what are the bandwidth requirements of those applications. Also, you know, when we look at how many clients, well, you know what, let's just take a look at these two graphics I have up here. In the first, and by the way, in these two graphics, the square footage is the same, okay? In that top graphic, we have a very small office with about 4 clients, and each client has a desktop, okay? So it's a very, very small office or very small population, very small client count, very small device count. Okay, so we can put one AP in there and rest assured that everybody's going to have a pretty good experience. Okay, now we look at the graphic on the bottom, same square footage, but what we have here is a cubicle farm. Okay, we've got 50 clients in here, and these clients have a desktop and they have a couple of personal items, BYOD. Maybe it's a phone, maybe it's a laptop, maybe it's a tablet. Okay, but we've got 50 clients with 3 devices each. Okay, and look what they're doing in this office. Okay, they're making Zoom calls. Okay, and they're each client is consuming about, you know, about 5.5 megabits per second. They're also transferring big files, back uploading, downloading, which is about 1.7 megabits per second. They're all using Office 365. There's other network traffic. And then if you're designing a new network, don't forget to add some growth, okay, some room for growth. Don't design a network that's already at the max, because I guarantee you, if 50 clients have 3 devices today, next year they're going to have 4 devices, okay? And then your network is already obsolete. So when you start adding up how much bandwidth each client consumes, you know, you're talking about a pretty big number. So overall, for those 50 clients, 3 devices each, we're looking at 1.3 gigabits per second. Okay, now when you start to look at, okay, well that's a good number. At least I know what the number is. It seems pretty big, but not unreasonable in today's world. How many radios do I need? That's where you go look at the specs, right? And you look at our XV3-8, and it says that it can do 1.2 gigabits per second. Okay, folks, don't forget, those are marketing numbers. If you want real world throughput numbers, take that marketing number, and it's not just us, it's everybody, okay? It's everybody who manufactures an AP. Take that marketing number and cut it in half. And that's gonna be a lot closer to your real life throughput. Okay, so we have this XV3, it does 1.2 gig, I need 1.3. I'll take that 1.2, cut it in half, that's what, 600 megabits per second. Okay, so I'm probably gonna need 3 radios in this area. Okay, that's, now knowing this, I can go to my Wi-Fi designer, select the AP. Okay, I need at least 3 radios. I'll probably put 3 access points, or 2 to 3 access points in this area. Okay, does that make sense? That right there is the hardest part, in my opinion, of getting the network correct, okay, is getting the math right. All right, next slide, please. Thank you. Okay, and you know, I've mentioned this several times already, but it holds true, okay? You you're going to design your network based on the environment that you're in. Okay, if you're in a warehouse, the ceilings are 30 to 40 feet in the air. Well, guess what? You can't hang just any typical access point on that ceiling and expect it to work. The omnidirectional antennas on these access points, not just us, but everybody, those antennas are not designed to shoot the power down. They're designed to shoot the power outwards, okay, sideways. So you hang it up there 30 feet, 40 feet in the air, power, very little power, is going to reach the client down on the floor. And let's face it, if you're in a warehouse, a lot of times they're using older scanner equipment anyway. Okay, so with the weak signal, then you're just asking for trouble. So you'll use a different type of AP in a warehouse. You might use we have an indoor AP that you can put external antennas on. Okay, so you can put that AP up in the ceiling. This is a 4 radio AP, so you can have 4 antennas, 1 antenna down each aisle. All right, these are external antennas. So now the power is being shot down the aisles so that the scanning equipment can reach it. Okay, then you have location services. Okay, if you're doing a location-based service design, that's going to be a little bit different. Okay, you're going to need more access points, and more times than not, you're going to put access points on the perimeter of the network because you've got to cover all those areas, right? In your typical office type of scenario, I don't recommend that you put access points in the corners or on the perimeter because a lot of your energy will be wasted going out into the parking lot. Okay, so those access points will be more towards the center of the room, of the area. Okay, and then outdoors, well, that's all different as well. You don't necessarily have the obstructions of walls and doors and windows and stuff like that, but you still have to plan for free air loss. Okay, even though that air wavelength is going, is flying through the air, just the air is going to attenuate it. So, in a vacuum, the signal will go forever, but we don't live in a vacuum. So even open air will attenuate a signal. So, that's a different scenario.
We have a great question here from Ryan.
Sure.
His question is, for quick, rough wireless designs, is it better to go with more smaller access points or a smaller number of large access points? And I'm going to bet you're going to say the answer is it depends.
It always depends, right? It always depends. Thanks, Ray. Yeah, I hate to be vague like that, but no, that is the right answer. You know what? You really want to look at the density requirements. How many clients? Okay, how many clients are going to get on in that area that you're covering, and again, what are they going to be doing? If you can answer those 2 questions, you can start to build your rough network. Okay, if you have a high density of people, like a cubicle farm, you're going to want to use the larger the larger access point because it has more radios. Okay, so it can distribute the users across a radio. Whereas if you the XV3-8 has 2 5 gigahertz radio. The XV2-2 has 1 5 gigahertz radio. Okay, high density, use the XV3-8. Low density, use the XV2-2. Okay, yeah, that would be my suggestion if you're just going to rough ball it.
Yeah, and Adam picked up on a nuance on the 4 pictures that you're showing right now. Adam says, in manufacturing warehouses, it's also good to know what is moving around and what's inside those containers. He says that they found it best to use Yagi antennas down the aisles versus the Omnis.
Oh yes, absolutely. Yeah. Yep, that's right, and that's where the XV3, I mean the XA4 is our internal access point that uses external antennas. And he's right. You know, when you look at this picture of the warehouse, you know, we see some cardboard boxes, right? You know, and some signal may pass through those, maybe not. But you know, one of our big customers is a wine distribution company. So they have these pallet racks full of wine, and guess what? The signal's not going to pass through the wine. You know, it doesn't pass through water. So yeah, in a warehouse type environment like this, if you put up regular access points with omnidirectional antennas, you're looking for trouble. It's just plain and simple. You need something more specialized. You need to be able to direct the energy down between the aisles on the floor. Because if you're one aisle over in this picture here, you're not going to be able to cover the other aisle. It's just not going to happen. There's too many things there that are going to attenuate the signal.
And Graven, pardon me if I mispronounced your name, mentioned that do you want to use an external antenna or an omni at the center of the room, or just as you were saying, that you might want to put something on the side walls at the end of the aisles to make sure that that signal goes down the aisle?
Yes, yeah, you would want to put the access point at the end of the aisle, and like I mentioned with the XA4, that's the 4 radio access point. And what we did for this wine distributor was we had an external directional antenna pointing down each aisle. Okay, so each aisle had its own radio, its own antenna. I like to do it that way for multiple reasons. Number one, the energy is getting focused where it needs to be, and number two, you know, when you're doing it that way, your channel planning later on becomes a lot simpler. Okay, because you're using less 5 gigahertz radios. These are good questions, guys. Thank you. Really thought-provoking, and also everybody gets to learn from the answer. So thank you. Okay, next slide, please. Oh, there we go. Thank you, thank you, thank you. So what happens with a bad design? And guys, if we've been in the business long enough, we've seen a bad design. And if you have a bad design, sometimes you can't recover from it. It's just really, really simple. You know, some of the signs of a bad design are like I list here, insufficient coverage, lack of scalability, and that's a big one, because again, if you have an area that today has 50 devices, next year it's probably going to be 75 or 100. So when you design your network, allow for scalability, allow for growth. Okay, lack of required functionality. Does your Wi-Fi vendor have guest access portals? Okay, what if that's required by the customer, but you forgot to talk about it, and you're not able to give them guest access portals, or even corporate access portals? Okay, that becomes a big problem. So that needs to be asked up front. Using the wrong equipment. Okay, what would happen in that warehouse scenario if we put an AP in the center of the room and expected those omnidirectional antennas to cover the whole warehouse? It's not going to work, and customers going to be very angry. Okay, missed devices causing interference. This is where that spectrum analysis comes into play, because if you have interferers in the area, okay, and they could be rogue access points, they could be something mechanical up above the drop ceiling that's causing interference. It can mess up the performance of your network. And here's a true story for you. I was working at the Orange County Convention Center in Orlando, Florida. Okay, huge Microsoft trade show, and there was this one area on the expo floor that Wi-Fi was terrible. And you know, if it's terrible, Microsoft lets you know about it really quick, as they should. But you know, nothing we did during that show could fix those Wi-Fi issues. Well, the next year we came in, But this time we had like a $7,000 spectrum analyzer with us. And we found out that a couple blocks away, there was this directional radio, a radio with directional antennas that was just pouring energy into that area of the convention center. Okay, but that's nothing that our regular spectrum analysis would pick up. But again, there was nothing we could do to fix that until somebody went and talked to the owner of that radio and asked them to, you know, adjust it, turn it off, or whatever. Once they took care of that, the problem was solved. Okay, but if you don't do a spectrum analysis beforehand, you won't know these kinds of things, and you're kind of running blind. You're just hoping that there's nothing out there that's going to get you in trouble. Okay, which leads to poor performance and poor roaming, and really it's just a bad quality of experience for the end user, and the customer's not going to be happy. So you know, there's no, I'll say this over and over and over again, there's no substitute for a good Wi-Fi network design, and that includes, you know, those discovery questions up front and doing your math right. Okay, next. Okay, so some design principles. In education, you know, here's a sad truth, or it's an easy truth. In education, more times than not, schools want to put an access point in every classroom, and it's probably not a bad idea, but I think that makes us complacent. Oh, it's a school, we're going to put one in every classroom and just kind of leave it at that. You know, you look at your auditoriums, well, maybe we put some, maybe we put 2 in the cafeteria and 2 in the auditorium, maybe 3 in the auditorium, depending on how big it is. So those are really, really easy. But you know, the dynamics are changing. You know, even in class, kids are using Zoom. Okay, so you know, where it used to be one-to-one, you know, kid would come in, the school would give them a notebook or a Google Chromebook or something like that, and that was their only device. But now kids are bringing their own tablets, their own iPhones, and Lord knows what else. Okay, so now each kid has 3 or 4 devices. That changes the dynamic. Is one access point going to be good enough? And is that access point a dual radio, 2.4 and 5, or do you need 2 5 gigahertz radios in that room? More than likely, you're going to need 2. Some of our larger school districts are actually putting 4 5 gigahertz radios in each classroom. Okay, classrooms are going to have a different density requirement than libraries, auditoriums, cafeterias. Okay, once again, you know, when you're designing, the bandwidth per client and the number of clients is going to determine the number of radios you use. And by chassis type, I mean, is it going to be an XV2 or is it going to be an XV3? Okay. Upgrade, AP upgradability. So essentially, you know, like with the XV3, that can be 1 or 2 5 gigahertz radios. And just a little tip of experience here. When you're using, you'll use the 1 5 gigahertz radio with 8 antennas, primarily when you have a 11AX client mix. Okay, it's primarily 11AX. If you have 11N, 11AC clients and a few 11AX clients, take that 5 gigahertz radio and split it into 2 with 4 antennas each. Okay, now do the numbers. Can you have 1 XV3 in each classroom? Probably. Okay, probably a good thing. But you know, can you do it with 1 XV2? I doubt it. Okay, because you're going to want that other 5 gigahertz radio. And here's another thing: be cognizant of things that will attenuate the signal. Stairwells, elevator shafts, bathrooms, places like this. Okay, they will absolutely kill a signal, but that's not always a bad thing. Okay, you can use that to your advantage. If you have an AP that's shooting out energy and it's and there's a bathroom or a series of bathrooms blocking the energy from the other side of the building, well, guess what? That gives you the opportunity to put another AP on the other side of the building. And if you had to, you can probably use the same channel or maybe nearby channels. Okay, so these attenuators can also be a positive thing. They don't always have to be negative. Alrighty, next please. Okay, so when you're doing your site survey, okay, and I highly recommend you do a site survey, an active site survey. An active site survey is where you send an engineer on site, okay, and they take the access point that's probably going to be used in that environment, and it's on a cart with the battery. They go to an area, and then you know, with the floor plan map, they go around marking the signal strength in different areas when the AP is in this certain area. So they go around and do the whole building that way, or all the floors or whatever. And this is the most accurate way to do a site survey. Unfortunately, it's also the most expensive, okay, because you have to pay the engineer to go out there and do that. And most customers just, oh no, I just want Wi-Fi. I don't want to pay for no, you know, no extra, nothing extra. No site surveys, just and then you're left doing the predictive site survey. Lots of different tools. We have a free Wi-Fi tool, Wi-Fi designer tool. It's cloud-based, and it does a pretty good job. Okay, it allows you to draw on walls or use an environmental setting, and then you can place the access points and you can determine the coverage. Now, you still have to be very diligent in figuring out how many radios you're going to need in each area, but at least this way you can get the coverage and the placement of the APs correct. Okay, I like those predictive site surveys. They will save you just about every time, but unfortunately, like I said, people don't want to pay for them. Okay, next one. So what's required to perform the site survey? You need a complete set of floor plans. Okay, and you know what? I've seen people use pictures of fire escape plans. Those work. Okay, but you're going to need to take that floor plan and import it into your Wi-Fi designer tool. Okay, identify the specific areas that need to be covered. Identify how many clients are in those areas and what they're going to be doing. Okay, and how much bandwidth is required in those areas. Figure out the type of devices. Again, that changes, you know, how much bandwidth or the RSSI signal strength. Okay, desktops don't require as much as laptops, as much as tablets, as much as phones, and then you have you know, medical equipment, which requires even a stronger signal. So get all that up front. Are you going to be using both bands, 2.4 and 5 gigahertz? I'm pleased to say that more and more companies are turning towards 5 gigahertz only. It's a lot faster. You get people on and off the network a whole lot faster. Doesn't always work, and so some people have to have 2.4 as well. Okay, look at the coverage areas. Again, look at the environment: warehouse, office, retail, you know, for location-based services, you know, things like that. So because each one of those type of environments is going to require a different network setup. Okay, the APs are going to be placed differently. Also, identify restricted areas. Okay, you're not allowed to put an AP in here. If you go into a hospital, a lot of times they will not allow you to put the AP in the patient room. Okay, it has to be out in the hallway, and then they get upset because the AP looks ugly sitting up on the ceiling. So you know, figure out what kind of restrictions you have. You know, just as much of this information as you can get up front will help you when you're doing your survey. Okay, next one. Oh, you know what? There's one on here I didn't talk about, the type of wall construction materials in the buildings. That's a really, really tough one. You know, we can look at a wall and we can say, oh, that's sheetrock. Yeah, you're probably right. It sure is sheetrock, but what's below the sheetrock? What's underneath it? Is it wood studs? Is it metal studs? Is it chicken wire? I've seen that. Okay, and that's where the active site survey absolutely saves you, because you know what kind of attenuation you get between walls and doors. Glass is another one that is all over the board. Just regular old plate glass, could cut the signal in half. Bulletproof glass will kill the signal 100%. Glass has different coatings on it, which affect the signal differently. Each coating will affect it differently. So, glass is a tough one. You just, I guess, kind of have to make your best educated guess there if you're using a predictive site survey. Alrighty, next. Okay, so a couple of these I've already mentioned. When you're doing your survey for both 5 and 2.4, but like I said, what I like to do is I'll survey for 5, and then I'll come back and make sure that 2.4 is covered, and 99.9999% of the times it is. It's just simple. Okay, survey for radio coverage of at least, and here I'm talking about the Xeris multi-radio access points. We have the XD4, which has 4 software programmable radios, and the XD2, which has 2 software programmable radios. So just make sure if you're using those, you're covering 3 5 gigahertz radios on the XD4 and 1 on the XD2. Okay, do not try to cover a parking lot with an access point that's inside the building. Likewise, do not put an outdoor access point on the edge of the building and try to cover the inside. Yes, you may get some bleed through the walls, but it's not going to be good for anybody. Okay, performance is going to be pretty poor. And just because the buildings look similar, don't assume they are. We learned this lesson the hard way a long time ago. We were doing multiple buildings for BYU. These were all dorms. And we went out there and did an active site survey on 4 of the 6 buildings. And so we sold them a network, guaranteeing it, saying, hey, this is what you need. If you need anything else, we'll pay for it. Well, we did the install, and sure enough, we got a call that one of the buildings, the Wi-Fi didn't work. And it was one of the buildings we didn't survey. All right. This building was the first one built at the turn of last century. Okay. And literally, there was chicken wire and plaster in the walls. Okay, so there was no bleed through, there was no going from room to room with the RF. So we bought a lot of access points because we had to stick one in every dormitory room. Okay, so once again, you can't see that kind of stuff in a predictive site survey, but if done properly, that active site survey would have saved us. Okay, if you're surveying a multi-floor building, start at the top. Okay, and then work your way down. Start in one corner or on one edge and work your way across the building. Okay, do not try to cover multiple floors with a single access point, hoping that the bleed through on the floors is enough to cover. You're just asking for trouble if you do that. Take pictures during your survey. A picture, we say, is worth 1,000 words. Well, if you're the installer, that picture is worth 1,000,000 words. Okay, will really, really help the installer when he gets out there. Because if you think about it, you know what? A ceiling tile is a ceiling tile. They all kind of look the same. So, take some pictures and make some notes for these guys. All right, if you're going to use 1AP for an active site survey, make sure that you survey out to neg 80, so that when you put that access point in the middle of the reception area, how far out can you go to neg 80 before you move that access point again. All right, again, pictures and notes are invaluable to the installer. So take as many pictures and notes as possible. Okay, next slide. I think we have a drawing of, some more best practices. So select clean and simple mounting options. And essentially what that means is, if you're in a gym, okay, and the floor plan or the design calls for you to put that access point smack dab in the middle of the gym, but you don't really have access to that high ceiling, it might make better sense to put that access point towards one of the walls where you do have access. Okay, but you want to balance the RF coverage. Don't mess up your RF coverage trying to make it easier on yourself. And this one's huge. Consider cable runs to the closet. Remember, these access points need power. Okay, so whether we use a PoE switch or a power injector, okay, just make sure that that cable going out to that access point is not over 100 meters, about 327 feet. Okay, you get beyond that, and you are slowly asking for trouble. All right, I've said this before, leverage existing cable pools if you can. If the AP has a monitor radio, a dedicated monitor radio, point that guy towards the outside of the building. Okay, the signals from the monitor radio are very strong. They're very long, and they travel and they travel and they travel. So you can point it towards the outside of the building and know that it's going to cover the inside as well. Just the back lobes will do that for you. But you want your client servicing radios pointed towards the inside of the building. Okay, you know, we talked about this. Isolate the RF energy as much as you can. If you can use a bathroom or a stairwell or an elevator shaft to help you contain your RF energy, that's even better for you. Okay, if you're in an office building or a school or a hotel or something like that, you know, it's very tempting to put access points in hallways. Try not to do that. Okay, they have direct line of sight with each other. If you absolutely have to, you better make sure your channel plan is correct. Okay, because if both those guys are on channel 36, guess what? Then you've only got one radio working at a time, and people are not going to be happy. Okay, so be careful if you have to do hallway installs. Okay. In a multi-story building, do not place access points right on top of each other. So on floor number 3, you've got an access point in the far right back corner. Do not put an access point on layer 2 in the far back right corner. You know, move them across, move them around a little bit so that they're not sitting right on top of each other. Okay, again, avoid placing those APs at the edge of the buildings because you have RF energy going out the building, and you know, that's just wasted energy. Check for available power. Well, remember, if you're using PoE injectors, each one of those guys has to plug into something, and more than likely it's going to plug into some kind of UPS, right? So make sure you've got power for all those, or use a PoE switch. Make it easier on yourself, cheaper for the clients as well. All right, and plan for a 20 to 30% overlap in cell coverage. And then I'll say this again, take notes, take pictures. All these things will help the installer. Okay, next one. And we'll go through these pretty quick. So here's an in-room deployment. My goal here was to show you how to avoid placing APs in the hallways within line of sight of each other. Okay, and next slide. Okay, this is kind of what it looks like when the APs are in line within sight of each other, line of sight of each other. Again, I recommend don't do this unless you absolutely have to, and if you do, make sure that your channel plan is correct so these guys are not conflicting with each other. Okay, and there's just kind of a little fun little graphic. All right, next one. Okay, so here is a good, this is good for RF coverage only. Okay, don't know much about the clients. This is a school, so you know, if the school is saying, hey, I just want coverage, I want to make sure that you know, the teachers can access the network, and kids, well, they can too, but I'm not really worried about the performance they get. Okay, so we have 2 radio access points in the classrooms, and we have 4 radio access points in the auditorium and the cafeteria. Okay, next. Okay, now here is 4 radios in each classroom. Okay, and these could be XV3s as well. And in today's world, with all the technology, you're going to see this design being used more and more and more. Yes, you can put a traditional 2 radio access point in each classroom, but I can almost guarantee you, you're going to start bumping your heads on the ceiling, okay? You're not gonna have enough bandwidth when all those kids sit down and the teacher says, open up your ebook and turn to page 325, okay? It's gonna take some kids a long time because they'll be waiting in line. Alrighty, next. Okay, more best practices. You know, higher efficiency, the Wi-Fi 6, higher efficiency, more clients, higher throughput, large public venues. Wi-Fi 6 is supposed to be 4 times more efficient. But in today's world, the reality is we still have a lot of legacy 11AC clients and even some 11N clients. Very few Wi-Fi 6 clients. They're still pretty expensive. So, you know, if you're designing a network today, I don't recommend making any changes for Wi-Fi 6. You know, just continue doing what you're doing right now. Next. And post-survey deliverables. When you're done, you've done the survey, you've installed the network, and you're going to sit down with the customer and show them, get them to sign off, right? You show them the new spectrum analysis. You provide the floor plans showing the locations of all the new APs and switches, okay? You show the location of all the existing APs and switches and ports available and things like that. You want to show the existing cable drops. You want to show them how their DHCP and Radius and syslog servers are being used by the new network. Mark areas of concern. Hey, I could not get into this area because it was restricted, and when I tried, the security guard told me to go away. Okay, make sure you note that. Okay, again, take notes, pictures, because you'll want to show these to the customer. And also, you know, show the specify the user density, verify these one more time with the customer. Okay, look, this area here is a cafeteria, and we could have 400 students, each with 3 or 4 devices. You know, this is the warehouse, you know, and there's nothing in there. So make sure you cover all that, as long as the heat maps and the bill of materials. Okay, and I think we're just about there. How's that for timing, guys?
You're spot on. There are a few here. There's a bunch. We'll try and answer a lot of them offline afterwards. One question that did come up really quickly: does Cambium Networks offer active site survey services for partners that don't have an engineer?
Not to my knowledge, Ray. Do you know of anything like that?
I do not.
You know what? Let me step back. We do have a professional services department, and
Right.
that might be something they would be willing to do. I'm not going to speak for them, yay or nay, one way or another, but I think it's worth bringing up.
Well, or one of our reseller partners probably.
And that's probably the better answer. But
yeah. Does the Cambium tool take into account the height of the AP when you're using the Wi-Fi designer?
Unfortunately not. Great question, but unfortunately not.
Okay. And let's see, does the Wi-Fi designer tool, looks like we need to have a webinar on the Wi-Fi designer tool. Does it show the effect of directional external antennas, for instance, on the E502 access point?
It does not. No, unfortunately.
Great. Well, thank you everybody for joining us. Looks like we're going to have another one in our series of best practices for Wi-Fi design. Thank you so much, Mark, and we look forward to seeing you on future webinars. Take care.
Thank you. Thanks for the invite. And guys, thanks for your time today. I appreciate it. Have a good one.